In this video, we'll take a look at how to configure Pi event frame-based batch reports introduced in version 2023 revision 2. First, let's introduce some terminology. We'll start with the new Pi Asset Framework Event Frames Batch History driver. In addition to the communications configuration here, we also model the event frames hierarchy. The existing batch definition manager has been updated to work with the hierarchical batches exposed from the event frames. A cluster is a new object that contains a set of user-configured reporting objects that will be tied to different levels in the batch hierarchy. A new batch object is placed on a report. This allows us to associate display clusters with batch instant levels or sublevels. The runtime calculation engine and report composer or renderer are responsible for finding the actual logged instances of batch sublevels with the associated timeframes, and then generates the report accordingly with the appropriate content for each phase or subphase. The general workflow is as follows. This, of course, assumes some basic working knowledge of Dream Report. Start the Designer Studio and then create a new reporting project, or open an existing project. In the Communication Configuration Wizard, configure an instance of the Pi Asset Framework Event Frames Batch History driver. Here, you'll also replicate the event frame structure from the Pi Event Frames Interface Manager. Additionally, you'll probably also want to configure the Pi Asset Framework Historical Values driver, which will expose the process data that you've logged in Pi, and also the Pi Alarms driver. You then open the Batch Definition Manager and add the event frame-based batch definitions from the driver configuration. While not specifically part of event frames configuration, we always suggest that you organize your process tags in a data model, in this case corresponding to the equipment model. We then create display clusters for each phase or subphase of the batch. These could include batch or phase details, raw data or summary tables, charts, etc. relative to a specific phase. Next, create a new report and place a batch object on the report. The batch object allows us to associate display clusters with batch phases and optionally make dynamic tag replacements when the report generates. That functionality will be covered in part 2 of this video. You can set the report generation to be event-triggered based on any real-time value, either from Pi Asset Framework Real-Time Values driver, an HMI action, or directly from a PLC. Finally, save and run the report. I'll start off by opening Dream Report Designer Studio and then creating a new project. When the Communication Configuration Wizard opens, we'll find and select the Pi Asset Framework Event Frame Historical Batches driver, and then configure a new instance of the driver. We'll enter the name of the asset server. If local to the Dream Report machine, you can use localhost, or enter the machine name or IP address. If using the asset server's machine name, you must use all caps. For the database, enter the specific Asset Framework database containing the event frames. You can get this from the Pi System Explorer. Enter your Pi credentials and then test the connection. Now it's time to configure batches for this driver. You'll see on the right side all the batch and phase template definitions from Asset Framework. What we need to do is create corresponding batch hierarchies in Dream Report. I'll give the batch configuration a name. It does not need to match anything in the Asset Framework. And then to see the actual batch hierarchy, we can open the Pi Event Frames Interface Manager. For example, we see a Coda batch definition here. I'll now add these phases over to mimic the hierarchy. These, of course, could be several levels deep. Switching back to the Pi System Explorer, we can see that some of these batches have run, with the top-level Coda batch template running first, and then several instances of different Coda phases being run after that. Finally, I'll add this named batch template and repeat for any others. I'll click OK to close out the driver configuration and add it to the defined drivers list. While I'm here, I'm going to also configure an instance of the Pi Asset Framework Historical Values driver. Since I'm connecting to the same asset server and asset framework database, I'll use the same connection details. For the data retrieval type, I'll just use the retrieval as configured in the Pi tags, but could set up any number of different retrieval types or rates. Let me add it to the list, and then we'll come back to this later on to add the alarms driver. We now need to open the Batch Definition Manager and add any batch templates we configured in the Event Frames driver. To add a batch definition, I'll click the Add button, and I can either choose Add Batch, which is the traditional way of defining a batch in Dream Report by a batch ID tag or a database lookup, or, in this case, I'll select Add External Batch. I can then select any configured historical batch driver, and then a specific batch template that we defined in that driver. Note that any parameters associated with each of these levels are exposed in Dream Report. Going back to the Pi System Explorer, we see recipe and line name attributes defined at the coder batch level, and equipment type at the coder phase. If any of those attributes are changed in the Pi System Explorer later on, you then need to open the Event Frames driver again in Dream Report and manually refresh the batch attributes by clicking this button. We're now ready to add clusters. On the left side Reports panel, we'll right-click to add a new cluster. I'll create two, one for the batch header information and one for the phases, as that is how the coder batches are structured. On the batch cluster, I want to add the overall batch information, so I'll add a set of single objects to a free-form table. We showed earlier that the recipe and line name attributes were defined at this top level, so we'll include them in this cluster. For the dynamic batch or phase name, we're going to introduce a few new system dynamic tokens, which can be found in the help file. You'll notice that the system token names are surrounded by $signs. I'll select the token for the batch or phase name and place it in quotes in an expression object. For the start, end, and duration of the batch, I'll use the standard batch functions in 3 single data objects. The time period definition actually doesn't matter here, as it will be dynamically determined from the event frames when the report generates. Now, for the recipe and line name attributes, we'll again use specific clustered dynamic tokens by taking the actual attribute name from the event frame template we saw earlier, in this specific format in expression objects. No $signs are used here, as these are not system dynamic tokens. I'll do a little formatting and then add one more object to this cluster, an automatic statistic table to summarize the overall flow rate for the batch. I'll select the Asset Framework Historical Values driver I configured earlier and select a coded tag or tags that I want to report on. Again, some formatting, and I'll place a background color to identify this as the report header section. For simplicity, I'm going to copy these two objects and place them on the phase cluster, with just some minor modifications. Since the phase template only has the equipment type parameter that we saw earlier in the Pi System Explorer, I'll delete the line name column and edit the recipe to reflect the equipment type named exactly as in Pi and using the same format for the cluster's dynamic token. I know that the equipment type is an integer, so I'll remove the string quotes and format the output accordingly. I'll reformat and change the object colors to distinguish them from the batch header objects here. Finally, I'll add a line chart to this cluster to trend the flow rate for each phase that was run. Remember, you can make the tags dynamic based on which phase was run, and we'll show this in part 2 of the Event Frames video. Now that the two clusters are configured, we need to create the actual batch report. And then place the clusters on the report. To do that, I go to the Batches tab, then select and add a batch object to the report. I'll name the object, and then select the batch definition we defined earlier. We simply need to select each level in the definition and then associate the relevant cluster to display. By the way, this is where we had defined process tag replacements if needed. Finally, this is where we specify the time period to report over. We'll use batch-based and then select the same batch definition. At runtime, all appropriate start and end times will be determined. I'll apply a page template that I created previously for my reports, which will give me a nice page layout. Now it's time to save and run the project. I'll configure the web portal so that I can dynamically generate and view reports from a browser. Here's the code of batch report. I'll select the dynamic report generator and select a batch from Pi to report on. Here we see the top-level cluster with a blue frame, giving us the overall batch information. This looks like a 6-hour batch that ran on December 5th. Then, underneath, we see repeating clusters of objects for each different phase that ran. For example, startup, loading 1, etc., along with each phase duration and any relevant process data over each phase. This results in a 15-page report in this case. Looking at the same event frame history in Pi, we see the identical information. The last thing I want to do is add any alarms or events from Pi for each event frame. In Dream Report Studio, I'll open the Communication Drivers wizard again, and this time select and configure the Pi Asset Framework Historical Alarms driver. I'll use the same Asset Framework connection details as earlier, and then I need to configure one or more alarm filters to work with. To get alarms from event frames, the severity property of the event frame must be something other than none. So I'll create a filter and I'll add that here. I'll now add an alarm table to the phase cluster, which will then show any relevant events or alarms in each reported phase. I need to add this filter using the Alarm Filter Manager and then select it for this table. For details on configuring alarm drivers and alarm filters, please watch the Dream Report alarm reporting video. I'll select a few fields from my table, format it, and then we're done. Finally, I'll save and reload the changes. When I run a report for a batch, we'll see the events table shown for each phase. There's unfortunately no real alarm data available in this Pi Historian, but we do see events for each phase. Additional configuration details can be found in the Dream Report help file. Thanks for watching.